Hello friends, welcome once again to my channel. I'm going to do a sum. Now we are still continuing with the topic of calorimetry, but in this problem you can read and find it is not based on the principle of mixtures. So I would rather say this is a numerical based on heat. So let's proceed. Now the question says, calculate the heat required to convert 3 kg of ice at minus 12 degrees C kept in a calorimeter to steam at 100 degrees C at atmospheric pressure. Specific heat of ice is given, specific heat of water is given, latent heat of fusion of ice is given, and latent heat of steam is given. Now, before I proceed with this sum, I would like to tell you one thing. Whenever you see there is a change in temperature due to heat exchange, the formula is Q is equal to mc delta T, where m is the mass of the substance, C is the specific heat capacity of the substance, and delta T is the rise in temperature, or you can say fall in temperature. If you are giving heat to the substance, delta T you can say is rise in temperature, but if you are taking heat from the substance, you can say delta T is the fall in temperature. So it is better to write delta T is the difference in temperature. Now this formula is involved only when heat is given to the substance or heat is taken away from the substance, leading to change in temperature. But during phase change, all of us know that during phase change there is no rise in temperature. So here, how will you calculate the heat given or heat taken by the substance? Here the formula is Q is equal to ml only, where once again m is the mass of the substance and L is the specific latent heat, or you can only say latent heat. Specific latent heat and latent heat is same, but specific heat capacity and heat capacity is not same. Okay, so in this problem once again I will draw the temperature graph to do the calculation. You have 3 kg of ice at minus 12 degrees C, which you are converting to steam at 100 degrees C. So let's proceed to do the sum. Solution. Let's draw a temperature graph. At minus 12 degrees C you have 3 kg ice. You want to take it to 100 degrees C steam, so you should get 3 kg of steam. From minus 12 degrees C, if you give heat to ice, it will convert to 0 degrees C ice. Again, if you keep on further giving heat at 0 degrees C only, this ice will melt, so you will get 3 kg water. You are still further continuing to heat it, so water will rise from 0 degrees C to 100 degrees C till you get water at 100 degrees C, and then further when you heat it, then obviously at 100 degrees C the same water will start boiling and you will get 3 kg steam. So you can see how many steps are involved. Let's count. 1 2 3 4. 4 steps are involved. Let's say in this step the heat given is Q1. In the second step, let the heat given be Q2. In the third step, let the heat given be Q3, and here Q4. Now as you can see, for Q1 it is change in temperature, right? You are giving heat and the substance is changing temperature. So the formula involved is mc delta T. Mass of ice is 3 kg. Specific heat capacity of ice, you have to find out the specific heat capacity of ice. Let's see in the problem how much it is given. specific heat capacity of ice is 2.100 into 10 to the power of 5. 2.100 into 10 to the power of 5, and delta T of course is difference. 12 minus 0, you'll get 12. So let's do this calculation. 3 into 2.100 into 10 to the power of 5 into 12. So here I am getting 756 and 4 zeros, this much joule. So this is the heat given to take ice from minus 12 degrees C to 0 degrees C. Now let's calculate Q2. Q2 is the heat required to convert ice at 0 degrees C to water. So here change in phase is involved, so my formula is ml. Mass is 3 kg and latent heat of ice, let's find out from this given data. Latent heat of fusion of ice is 3.35 into 10 to the power of 5. 3.35 into 10 to the power of 5. If you do this calculation, you will get 1005 and 000 joule. So Q2 we have calculated. Now let's proceed to calculate Q3. Now as you can see, for Q3 here, ice at 0 degrees C, water at 0 degrees C has converted to water at 100 degrees C. So again there is difference in temperatures. Formula involved is MC delta T. Now the mass of water here is 3 kg. Specific heat capacity of water, let's see in the problem how much it is. Yes, specific heat of water is 4.186 into 10 to the power of 3. So 4.186 into 10 to the power of 3, and the rise in temperature delta T for Q3 0 to 100, so the delta T is 100. If you do this calculation, you will get 1255,800 joule. Now the last term, Q4, how much heat this water at 100 degrees C needs to convert to steam at 100 degrees C. Q4. So once again there is change in phase, so the formula is Q is equal to ml. Mass is 3 kg and latent heat of steam, let's find out how much it is. It is 2.256 into 10 to the power of 6 given in the problem. 2.256 into 10 to the power of 6. So it is 6768000. So the total heat involved will be simply the addition of all the terms, Q1 plus Q2 plus Q3 plus Q4. Let's add. Now Q1 is 756 and 4 zeros plus 1005 000 plus 1255800 plus 676,676,800. It will be 000. So if I do the full calculation, here I am getting 10497600 joule. Thank you guys for watching my video. Stay tuned for more